Picture this, a massive object hurtling through space at over 130,000 miles per hour. It didn't come from Mars. It didn't come from Jupiter. It came from outside our entire solar system. And right now, it's passing through our cosmic neighborhood for the first and only time in human history. On July 1st, 2025, astronomers detected something extraordinary, the third interstellar visitor ever discovered. They called it 3-Eye Atlas. Within weeks, the James Webb Space Telescope, Hubble, and observatories around the globe turned their lenses toward this cosmic traveler. What they found has left scientists scratching their heads and rewriting what we thought we knew about comets. This is the story of an object that's traveled billions of miles across the galaxy, carrying secrets from another star system. And we only have a few months to study it before it disappears forever. Let's rewind to early July 2025. The ATLAS survey, that's the Asteroid Terrestrial Impact Last Alert System, is essentially Earth's early warning system for dangerous space rocks. It's a network of robotic telescopes scattered around the globe, constantly scanning the sky for anything that moves. On July 1st, the Atlas telescope in Chile spotted something unusual. A faint dot of light, about 420 million miles from Earth, moving fast, really fast. When astronomers calculated its trajectory, they realized something incredible. This object wasn't orbiting the Sun. It was flying through our solar system on what's called a hyperbolic orbit, a one-way ticket through the neighborhood. The 3-Eye designation tells you everything you need to know. The I stands for interstellar. The 3 means it's only the third confirmed visitor from beyond our solar system. The first was Oumuamua back in 2017. The second was 2I/Borisov in 2019. But 3-Eye Atlas, this one's different. And scientists immediately knew they had a once-in-a-lifetime opportunity. Here's why this is such a big deal. This comet formed around a completely different star, possibly billions of years ago. And it's giving us a direct sample of materials from another planetary system. Now, this is where things get really interesting. When the James Webb Space Telescope locked onto 3-Eye Atlas in early August, scientists were expecting to see a normal comet, lots of water ice, some dust, maybe carbon monoxide. What they found instead was shocking. 3-Eye Atlas is absolutely packed with carbon dioxide. We're talking an 8-to-1 ratio of CO2 to water, the highest ever recorded in a comet. That's 6 standard deviations above what we normally see. In scientific terms, that's the equivalent of finding a human who's 9 feet tall. Martin Cordiner from NASA's Goddard Space Flight Center put it perfectly. Water is normally the dominant thing in comets. In this case, it's not. The comet is essentially surrounded by a massive bubble of carbon dioxide gas that extends over 216,000 miles from its nucleus. That's almost the distance from Earth to the Moon. Meanwhile, water vapor, which should be the star of the show, is barely there. But wait, there's more. The Very Large Telescope in Chile detected something even stranger, unusually high levels of nickel in the comet's coma, that glowing cloud of gas around its nucleus. And here's the kicker. The nickel-to-iron ratio is all wrong. In normal comets, these metals appear together in roughly equal proportions. In 3-Eye Atlas, there's way more nickel than iron, at least initially. Oh, and let's not forget the cyanide. Yes, cyanide. Lowell Observatory astronomers detected it in late August. Don't worry though, 3-Eye Atlas won't come anywhere near Earth. At its closest, it'll be about 170 million miles away, which is perfectly safe. So what's causing this bizarre chemistry? Scientists have a few theories, and they're all fascinating. Theory 1, the formation zone. 3-Eye Atlas might have formed in an extremely cold region of its parent star system, way out beyond what's called the CO2 ice line. Think of it like this. Close to a star, it's too hot for carbon dioxide to freeze. It stays as gas. But far enough away where temperatures plummet, CO2 can condense into solid ice. If 3I Atlas formed in one of these frigid zones, it would naturally have more carbon dioxide baked into its structure. Theory 2. Cosmic radiation. 3I Atlas has been travelling through interstellar space for possibly billions of years, bombarded by high-energy particles that could have stripped away lighter compounds like water, leaving behind a CO2-rich mantle. And Theory 3. Evaporative cooling. As carbon dioxide sublimates, it absorbs heat like sweat, cooling your body, preventing water ice from sublimating as quickly. The water's there, just locked inside. The truth? It's probably a combination of all these factors, and that's what makes 3I Atlas so valuable scientifically. It's telling us that planet formation around other stars can be dramatically different from what happened in our solar system. Here's something mind-blowing. The carbon isotope ratios in 3I Atlas, the mix of carbon-12 and carbon-13, are surprisingly similar to Earth's. That suggests the chemistry that built this comet might not be as alien as we thought. We might be looking at universal processes that happen around many different stars. Let's talk about 3I Atlas's grand tour through our solar system. The comet entered on a hyperbolic trajectory with enough speed to escape the Sun's gravity entirely. It swooped past Mars on October 3rd at just 18 million miles, reached its closest approach to the Sun on October 30th, and by Halloween, Chicheng-Jiang at Lowell Observatory captured the first images of it emerging from behind the Sun. As it got closer to the Sun, 3I Atlas developed a beautiful tail that grew to over 35,000 miles long. Classic comet behavior. Right now, in early November, it's already heading back out toward the outer solar system. By December, it'll be too far to observe. And then it'll keep going, past Pluto, eventually leaving our solar system entirely and returning to interstellar space. We'll never see it again. So why does all this matter? Why should we care about a chunk of ice and rock passing through our solar system? Because 3I Atlas is a messenger from another star system, possibly billions of years old. By studying its composition, we're learning that planet formation can vary wildly across the galaxy. Some systems might be carbon dioxide-rich factories. Others might be dominated by water. This diversity tells us something profound. There might be countless ways that planetary systems and, potentially, life can form. Comets like this have even been proposed as delivery vehicles for life's building blocks. When you look at 3I Atlas, you're not just seeing a comet, you're seeing a time capsule that might carry the same materials that led to life here on Earth. And here's the exciting part. We're getting better at finding these objects. Atlas, Pan-STARRS, and the upcoming Vera Rubin Observatory will likely discover many more interstellar visitors in the coming years. Each one will be a unique sample from a different corner of the galaxy. 3I Atlas has already taught us that our cosmic neighborhood is far more diverse and interesting than we imagined. It's shown us that comets from other star systems can have completely different chemistry from our own, and it's reminded us that we're part of something much larger, a galaxy full of planetary systems, each with their own unique story. As 3I Atlas speeds away from us, back into the cosmic ocean it came from, it leaves us with more questions than answers. Where exactly did it come from? How long has it been traveling? What secrets about its parent star system will we never know? But that's the beauty of science. Every answer leads to new questions. Every discovery opens new doors. 3I Atlas came to visit for just a few months out of what might be billions of years of existence. We were lucky enough to be here, with telescopes powerful enough to study it. We seized that opportunity, learned what we could, and now we watch it go. Somewhere out there, right now, another interstellar visitor might be heading our way, and when it arrives, we'll be ready.